If you take a slinky and hold it by one end with the other end dangling, and then let it all go, the top end of the slinky falls to the floor, but the other end doesn't. It just kind of sits there. Only when the top end meets with the bottom end of the slinky does then the entire slinky continue to fall to the floor as a whole. What's up with that? Let's take a look. Alright, let's have a go at explaining that. Some people will say it's because the information that the slinky is no longer being held hasn't actually reached the bottom of the slinky, so it doesn't know that it should be falling. Only when the top of the slinky, which carries the information, reaches the bottom, does the entire slinky know that it isn't being held, and therefore should fall. That explanation is both an easy way to explain what is seen without going into science, and really an oversimplification of complex ideas that are, I guess, beyond a lot of people. Let's have a look at some science of it. I prefer to look at it not in terms of information, but forces and potential energy. The force pulling the slinky down? Well, that's gravity, which of course is working on all parts of the slinky from top to bottom, not just the top. Prior to letting the slinky go at the top, the elastic force of the slinky was equal to, but in the opposite direction of, the gravitational force, so no net movement. After the top was let go, the elastic potential energy of the slinky became less and less as it was converted or transformed into kinetic energy at the same rate. So the slinky didn't fall nor collapse upwards. When the top met up with the bottom of the slinky, the elastic potential energy was zero, i.e. no more elastic force. So what happens? Gravity says, I win, and the entire slinky falls down to the floor. Here the videos slow down even more. If you watch carefully, you'll note that the top of the slinky actually descends to the bottom of the slinky at a faster rate than the slinky then falls to the floor as a whole. So what's with that? Gravity slacked off once the slinky was all together? No, not quite. Remember that elastic force? It wasn't only holding the slinky up against gravity, it was also pulling the top down, once the top was let go, towards the bottom of the slinky. So the top was initially accelerated downwards by both gravitational force and elastic force of the slinky. Once all together, the entire slinky was only accelerated by gravity, so fell at a slower rate.